Hi friends, today I'm going to read you Charged Up, the story of electricity. It was a bright sunny morning, but the weather forecast said there was a storm on the way. Thick gray clouds rolled into view, and by noon there wasn't a patch of blue to be seen. The sky grew dark and gloomy. In town, lights went on in stores and offices, and drivers turned on headlights. It looks like rain with some thunder and lightning ahead. People turned on lights at home, too. They continued what they were doing, cooking meals, cleaning the carpets, and playing computer games. The power that was making all the lights, ovens, and computers work was electricity. Electricity travels through wires. It flows along them in much the same way that water flows through pipes. The flow of electricity is called a current. Electric current is made in power plants and sent all across the country along giant spiderweb of thick, heavy wires called power lines. Electric current moves incredibly fast. It zips along at thousands of miles a second. That's quicker than you can blink. Yee-haw! Let's go, guys! Power plants turn one-of-a-kind energy, or power, into another. Most of the power the town used came from a hydroelectric power plant. It turned the energy of falling water into electricity. I don't care what you say, I'm not going down there. Billions of gallons of water from the lake above the power plant poured into huge pipes as wide as buses. The pipes led to a row of machines called turbines inside the power plant. The turbines were like fat metal wheels divided into sections by metal blades. As the water rushed down each pipe, it crashed against blades and made the turbine spin, the same way a revolving door spins when people push through it. Phew, that was making my head spin. The water raced down the turbine and out on the other side into a river, which tumbled away down the hillside. Water's job was done. All it had to do was make the turbine spin. See, I told you it was a waterfowl machine. As it spun, the turbine turned another wheel inside a machine called a generator. The generator wheel was made of magnets, and magnets gave out a special force called magnetism. When magnets whirled around, their magnetism made an electric current move inside some metal bands. The current flashed down from metal bands into wires, which took it out of the power plant. Life's one big whirl in this place. And it took it into a transformer. The transformer's job was to give a current a boost so it could travel farther along power lines. Otherwise, it would gradually lose some of its strength and stop flowing. The current raced out of the transformer into power lines. Those were lifted high above the ground on giant metal towers called pylons. The pylons carried the lines away from the power station and across the countryside. Meanwhile, high up in the sky, the storm clouds billowed and tumbled. Fat raindrops of rain splashed down, but the clouds weren't only stuffed with raindrops. They had millions of ice crystals in them. Inside tumbling clouds, the ice crystals bumped and pushed against each other. As they bounced around, they began to build energy. Watch out! Before long, the clouds had so much energy they couldn't hold it any longer. Crack! Crack! A blinding flash of lightning leaped across the sky. Lightning strikes in an instant, and even hotter than the surface of the sun. It's made of another type of electricity called static electricity. The lightning headed for the ground, but it didn't get there. Instead, it hit a power line. Eek! The power line was carrying a current toward town. When the lightning hit it, everything came to a stop. Hey, I was winning. Turn it back on. Lights went out. Televisions and radios died, ovens stopped cooking, and computer screens went blank. It was as if someone had thrown a gigantic blanket over everything. It was a power failure. Far away at the control center, an alarm flashed on a computer screen. Uh-oh, we've got some trouble. The alarm told the technicians there was a problem with one of the power lines. The technician guessed the storm was to blame. They knew they had to get electricity back to the people in town as quickly as possible. As a team of technicians headed to inspect the line, "Good luck," The technicians knew that lightning must have sent a huge jolt of extra electricity into the power line. This extra jolt of electricity had set off an alarm, and safety switches at the end of each line had automatically turned off the current. This looks like the one. Everything seems fine here. Before the current could be switched back on, the technicians had to make sure the line was no damaged. Luckily, the line was okay. The switches were turned back on and the current whizzed along again. Everything went back to normal. The current flowed along the power lines until it reached the edge of town, and then it was fed into another transformer. This transformer made the current weaker, so it was safe for people to use. The current traveling along the power lines is so powerful, it would burn out most of the electrical machines we use. That is, if it didn't have a transformer. Next, the current was split up and sent to different parts of town. Some of it went into wires stretched between tall poles, and some of it went underground. The poles carried the current away to a large factory at one side of town, and to a large farm on the other side of town. The current that went underground traveled along thick cables beneath roads and sidewalks. This one's really a live wire. Some of the cables led to street lights and traffic lights. Phew, thank goodness the lights are back on. Others snaked off underpass and gates into yards and all of the other offices, stores, and houses in town. Inside the houses, each cable led to an electric meter. This measured how much electricity the house used. From the meter, another carried the current into a circuit breaker. This works like little safety switches on a power lines. If too much electricity suddenly flows into the house, the circuit breaker switches the current off. From the circuit breaker, wires spread out all over the place. They traveled under floorboards, inside walls, and across ceilings. They led to light switches and light bulbs and plugs. The plugs led to heaters and to hair dryers, toasters and televisions, telephones and fridges and washing machines, and all of the things that we use every day because we use electricity. So, the next time you reach over to turn on a switch, just think your switch is connecting to a power plant that makes electric current. Current is made stronger by a transformer. The current flows along power lines carried on pylons. A transformer near town makes the current weaker and splits it up. Some current goes into underground cables. Some currents get carried into wires by poles. Poles carry the current to a farm. Poles carry current to a factory. And finally, underground cables carry the current to the rest of the town. Thousands of feet of wires and hundreds of pylons and machines and people. It's bringing electricity all the way from the power plant to light up your bedside lamp, all in the time that it takes for you to say, click. There's more great stuff to know at the back of the book if you're curious. There's a section called Steaming Along, Boxes of Energy, Static Power, What a Shocker. There's also a little activity at the end about connecting together an electric circuit. Let me know if you'd like to borrow the book to check out more at the end. Thanks, friends, for listening.